Hello everyone and welcome back to the Kia Ora Theatre at Linux Conference Australia 2022. Our next presentation is pre-recorded, so I'm the only person talking to you right now, but we will get pre-recorder Paris in here soon. So Dr. ParisButtfield-Addison is the co-founder of independent game development studio Secret Lab. Today he is here to help us learn about Godot. Oh, I didn't check how to pronounce Godot. We'll learn in the talk. Take a tour of its features and powerful scripting system, and quickly build a game showcasing the Godot editor for macOS, Windows, and Linux. Paris is available in chat throughout, so feel free to ask questions as we go. Take it away with pre-recorded Paris.
Hi everyone, welcome to Let's Make a Game. My name is ParisButtfield-Addison. You can tweet at me at ParisBA. I'd love to hear from you. Please feel free to do that and let me know what you think. Questions about Godot, anything else, or just want to tell me you like my glasses, which is a common comment. I am a video game developer, best known for working at Secret Lab, which worked on Night in the Woods, lots of O'Reilly books, lots of technical books, and the Yarnspinner narrative game tool. Today, I'm here to talk to you about a fantastic and completely free and open source game engine named Godot, or Godot, depending on how you pronounce these things. Godot is a fully open source project that really genuinely competes with the big mainstream commercial video game engines like Unreal and Unity. It is named after the play, with pictured here starring Patrick Stewart and Ian McKellen. That was a fantastic play, but starring many people over the years. It is a powerful little game engine. It is a project of the Software Freedom Conservancy. The Software Freedom Conservancy shepherds a lot of projects, and Godot is one of them. They make sure that the project is compliant with their open source licenses and that other people are compliant with the license when they're using them. But Godot really is an astonishingly powerful game engine. It is one of my favorite free and open source projects. It has many of the same features as the big commercial projects and really competes with them, but it's entirely free and open source. It has good UI, good UX. It's quite easy to develop with. It's powerful. It can deploy to almost every platform you can think so. Today I'm going to take you through building a little game, very simple game, from scratch, and talk about how and why you can use Godot to do this sort of thing. Hopefully by the end you'll see why it's really powerful and how it's easy to use. I'm not going to structure this as a tutorial. This is more just going to be enthusing you about Godot, so don't necessarily try and follow along. I really hope you enjoy. It's a really good, fun, relatively cheap hobby to build little video games. Share it with your family and friends. Let's jump in and get started. So we'll see how it goes. Here's Godot, open on my macOS device. Godot runs on pretty much anything, Linux, macOS, Windows. You can see it running in the dock there. It's got this cute little robot icon. So in Godot, Godot's actually written in Godot. So the game engine itself that you're using to write your game is actually built using Godot, which is a pretty cool thing and a pretty cool proof that it's actually a pretty solid thing. I'm going to click the new project button to make a brand new project. Well, hopefully that works. And we're going to call it Paris and Tim's Game, because we designed this this game together with Tim Nugent, my colleague, for using in talks and tutorials. And I'm going to select OpenGL 3 and create an edit. And it's going to make a brand new project in Godot. And I'm just going to maximize Godot there. So this is Godot. Godot looks like most 3D tools and most game engines. It has a 3D environment for you to navigate in and move around in. It operates on 3 different axes, X, Y, and Z. And you can manipulate the scene using those axes in the corner there. So we're not going to go into too much detail on how to navigate in 3D. Hopefully many of you have used Blender or a similar 3D tool, but if you're not, it's not too hard. My only recommendation would be, if you are using a laptop, maybe plug in a mouse if you're not super confident using the trackpad to do this kind of thing. So this is our big formless void that we exist in here in Godot. And we're going to turn this formless void into a video game. To turn this formless void into a video game, it's empty at the moment. We're going to add a node to the scene. Our root node for the scene is kind of going to dictate what kind of scene it is. So everything in Godot is made up of scenes with nodes in them. Here are the options for the various kinds of root nodes we can create. We're going to make it spatial. So a spatial node is a basic 3D parent in Godot. So everything that is kind of 3D descends from this spatial node in Godot. Spatial node doesn't really do anything beyond have a transform, a space, a thing that makes it exist in the space in a certain position. So here is our spatial node. It's currently just called spatial. It's very unexciting. We can add additional nodes below this spatial node as we desire, and we'll be doing a lot of that today. So this is our spatial node here in the node list, in the node viewer. We're going to add another node while our spatial node is selected. It's going to be a mesh instance node. A mesh instance node references a mesh and lets us have something visible in the scene. So a mesh is any kind of 3D object. It could be a primitive 3D object like a cube, or it could be something you've rendered in Blender. So node is the parent of all things in Godot, and then we're using spatial node, which is below it, and then there's this hierarchy of nodes which dictate how things work. So a mesh instance is a child of spatial, and spatial is a child of node. So we've now got a mesh instance as a child of our spatial node. We're going to make a cube. So over here in the inspector, while our mesh instance is selected, over on the right side of the screen, we're going to add an actual mesh. So we're going to click the empty mesh area, and we're going to go New Cube Mesh. If we wanted to, we could import an actual mesh from like Blender or one of the commercial modeling packages here if we wanted to. But Godot, like most game engines, ships with a bunch of primitive you can use. So now it's our lovely cube. As you can see, our video game is basically done. We're going to go to the material section and go New Spatial Material. And we're going to set it to a color, because we want our video game to be nice and colorful. So, what color should we make it? Maybe, yeah, orangey. Yeah, this is a good color. So this mesh cube is going to be our floor for our video game. So our floor is going to be a nice, egregious, orangey brown kind of color. That looks pretty good. So we've got our nice orange cube. So, with our cube made, we're going to select the mesh instance over in our inspector again, and we're going to click the little mesh button in the top of the screen. This button allows us to create a static body for the mesh. So this body will allow the mesh to collide with things in the world. Currently it's just a picture of a cube, and by clicking this button we give it a static body which allows it to collide with things in the physics engine that Godot ships with. So video games often have really high resolution complex meshes. So you need to create a fancy collision body to map to it, because you can't use the mesh itself as the collision body for performance reasons. In older video games, you'd often use the mesh itself as the collider. These days, you kind of want to make a simplified mesh that goes around it to serve as the collision body. You technically don't have to do that. Because we're doing it with cubes, we could get away with just using the cube as the collision body. But good practice in video game development is to create a collision shape that is a simplified version of the thing you're actually using. In this case, the simplified version will just be another copy of a cube, but using that create mesh button means you're doing it properly. So a static body in Godot is a thing that exists in the physics engine but doesn't move, or is at least strongly discouraged from moving. So there's a different type of body with a collider you would make if you wanted it to move, and you'll see that a bit later. So I'm going to select the mesh and push the R button, which switches to scaling mode, and you can see the different tools we can use here. So I push the R button on the keyboard, and I'm going to squish the cube a little bit to make a floor. This is just changing the transform of the cube. It doesn't mean I have to do anything precisely. I could just make a floor, basically. So I could also use the transform inspector to fiddle with it here. So I'm going to make it bigger, 10, and I'm going to make it half high, and I'm going to make it 10 again. So now we've got a nice, big, flat floor. It's orange. So most video game engines have kind of settled on this approach where you have objects with parameters attached to them. Commercial alike, Unity, Unreal, Godot, Game Maker, all of them have this kind of component-based architecture that they use to give things behaviors and parameters. So you attach things to things, and some of those things have parameters. In Godot's case, you have nodes and you have components attached to those which give you properties. Yeah, it's very common. This is not just a Godot thing, this is a generic game development thing. I've just renamed the spatial node to floor. So I've right-clicked on it and gone rename and called it floor, because it's a floor. So our scene is currently unsaved. We need to save it. So to save it, I'm going to push Command-S on Mac or Control-S on Linux or Windows. Floor.tscn is good. I'm going to just save it. So now we've got a floor scene. It's saved. You'll see down here in the File System Inspector, we have a copy of that floor scene available to us now. That's everything for the floor. So Godot actually does something quite interesting, and many other game engines now inspired by Godot and are doing it as well. Godot builds everything up out of scenes. So you can actually nest scenes within each other, and we'll see how that works later on. You might have like a player scene, you might have multiple player scene, you could load multiple instances of one scene into another scene. So you kind of use scenes as this basic object format which you can then load into other scenes, so you can replicate things and then only update the original for creating it. It's very useful. Godot and Unity really lean on this heavily. So speaking of scenes, I'm going to make a new scene right now with the scene menu, and now we'll end up with an empty scene. You'll see the floor still is up there. I'm going to do pretty much exactly the same thing as I did last time and add a new spatial node. Inside that spatial node, I will add a mesh instance, exactly the same as I did last time. Inside the mesh instance, I will create a new mesh again, another cube, and I will create another material and set a different color on this mesh, and we'll have to have a think about which color. Maybe yellowy. Yeah, yellow's good. No, a bit too green there. Yeah, yellowy. Yellow's good. That's disgusting yellow. Love it. Perfect. I'm going to create another tri-mesh static body for our mesh, because it's also going to be static, and I'm also going to scale it a little bit by modifying the transform. I'm going to make it 0.25, 1, and 10. So this is going to be a nice wall for us to use. So you'll see we've made a little wall here. I'm going to rename the spatial node to walls, and I'm going to save that scene. So it's going to be called walls.tscn. Now we've got two scenes open. We've made two fantastic scenes, a floor and a walls, both egregious, disgusting colours. I'm going to make yet another scene now, and I'm going to add a spatial node to that scene. Yep, spatial node, done. I'm going to rename the spatial node to environment. This scene is going to hold our level. This is going to hold our world that the player has adventures in. So I'm going to select the spatial node and click the link node. So the add node lets you add new fresh nodes to the scene, and the link node lets you bring in existing scenes. So I'm going to click that link button, and you'll see my two scenes I already saved before. I'm going to click the floor. So now we've linked the floor scene into our new scene. So anything we modify in the original floor scene will take effect in this scene because they're linked. I'm going to now do the same thing again. So I'm going to select the environment node. So it's going to be a child of the environment. And then I'm going to select walls. So now you'll see my walls are on top of my floor. Well, actually embedded in it right now. I'm going to use the move tool, W on the keyboard, and I'm going to move the walls to be, actual walls. I'm going to move them over here. It's not snapping very nicely, so I'm going to actually turn on snap by selecting the snap button or pushing Y on my keyboard, which will make it snap. You can configure the snap and how it works, so what parameters it snaps to. I'm going to switch the view to the top so I can see it nicely to align my walls. Now I can use snap to place the wall in the right position. I'm going to select the walls and push Command D on my Mac or Control D on Linux or Windows and duplicate my walls. Again, these are all linked copies of the original walls scene. So if I went into walls scene and made it less egregious yellow, it would change all the copies of the wall. I'm going to duplicate the wall again. So we've got 3 walls now. This is pretty common in most games. You duplicate things, move them around in 3D space, duplicate things, so on and so on. So this time I need to rotate it. So with the wall I need to rotate selected, I'm going to go to the transform inspector and I'm going to rotate it 90 degrees on the y-axis. So it's flipped around, exactly how we need it. Then I'm going to move it and duplicate it again and put it down at the bottom. So now we have 4 walls on our scene. I could fiddle with the snapping a little bit to make it more precise, but this is how you do that. I haven't got the energy to do that right now, so I can make it 0.5 on. I guess I'm not as lazy as I thought I was. So now I can snap it a little bit better, nice and precise. It looked good how it was. I'm going to leave it. Now I'm going to save this as environment.tscn, so Command S or Control S and saving. Now I've saved the scene. We've got this beautiful scene up and running. Look at that. It's beautiful. Our game is almost done. So obviously I need to move the walls up a little bit, so I'll just slide them up a little bit. They're not quite in the right position I want them to be in, so I'll move them all up while the snap tool is still on. This one and this one. That looks great. Now they're much more wallish than they used to be. Beautiful. So I'll hit Command S to save it. Beautiful floor. It's great. We're nearly done. We're not actually done, no. Okay, so now I'm going to rename the floor to lower floor, because we're going to have an upper floor in a minute as well, and we don't want to get confused. I can put spaces in it. I am just used to not having spaces in files. I'm going to link another instance of floor. Whoops, no, I'm going to link another instance of the floor scene, sorry. There we go. I don't want to nest myself in myself there. So now we have two floors. They're exactly in the same place right now, so I'm going to move one of them up a little bit and put it over here. So now we have an upper floor and a lower floor. Isn't that fantastic? Look at them. I'm going to rename it so it's upper floor and I don't confuse myself. Again, you can have spaces. I'm just old school. So with our two floors in place, we can move on. So, two floors. What else do you think we need? Well, we might need an additional way to get between the two floors. I'm not going to put any walls on the upper floor. I'm actually going to make a brand new scene again and repeat the process that we've done so far. Add a spatial node, add a mesh instance. First I'm going to run this ramp actually. Now I'm going to add the mesh instance. And with my mesh instance I'm going to create a... Oops, I didn't create a mesh. I'm going to create a mesh on this new mesh instance. So we actually have something visible. So on our mesh instance, I'm going to select the mesh instance, and unlike a second ago, I'm going to create a new cube mesh and pick a new egregious color. So maybe like another greeny yellow egregious, I don't know, maybe, green. Yeah, maybe nice and green. That looks good. Okay, the green really screams ramp to me. So big ramp energy. So I'm going to create my static collider again and modify the transform of this mesh to make it more ramp-like. So maybe 1.44, 0.1, and 5.47. Yeah, I think that's good. That looks like a ramp to me. I totally did not prepare those numbers in advance. That's beautiful. I'm going to save that scene as ramp.tscn. Done. Beautiful. Back in our environment, so I switch the tab at the top there. I'm going to link in the ramp. So add the node via the link button as a child of environment. So we're going to select that link button, and we're going to choose ramp.tscn. And with the ramp in the scene, you'll see it's embedded in the floor currently, so we're going to move it up a little bit. There it is. It is facing the wrong way, but we'll fix it in a moment. We control the universe, so it doesn't really matter where anything goes. So we'll hit the rotation button, and then we'll use the rotation button to rotate it a little bit. Look at that. That's beautiful. Rotated, and then we'll move it across a little bit using the move button and rotate it a little bit more so it actually is a ramp. And we've got a ramp happening there. That's great. That's close enough. That's kind of good, I think. Yeah, it looks nice to me. I'm going to save that just so it's preserved. We might clean that up a bit in the future, but right now our game is almost there, but we are missing one crucial thing: a player. So I'm going to make a new scene. The scene is going to be our player. We could have put all of this in one scene and made all of these things out of nodes, but then it wouldn't be following a nice reusable game architecture, because when you're building video games, it makes sense to make things out of composable pieces so you can reuse them as you need. In a multiplayer game, you might have a player scene that is instantiated multiple times and connected to different inputs, some over the network, for example. And by doing it like this, even when you're making a silly little sample game, it helps you keep things reusable. So we're going to create a kinematic body. Kinematic is a fancy word for it moves. So unlike our static body, the kinematic body can actually move around. So we need a mesh as well. So below our kinematic body, we're going to have a mesh. It's not going to be a cube this time. We're going to make a capsule, because the traditional prototyping mesh for a video game is a capsule. Prototyping is always a capsule. We're going to pick a nice egregious color for our player. Maybe blue, yeah, I think blue today for our player. That says player to me. Nice blue player cube. We're not going to rotate it up. We'll rotate it up later. So we're going to click on mesh, click kinematic body, and click collision shape. This allows us to represent this in the physics engine, but this means it can move as well. It's not a static thing. Our collision shape must have a shape attached to it. So with our collision shape selected, we need to go over to the inspector on the right and allocate a shape to it. So our collision shape has a little error on it. That's because it doesn't have a shape assigned to it. So in the inspector, we're going to go across and give it a shape. And surprising nobody, it's going to be a capsule. So this is the thing that's actually represented in the physics engine for this shape. And coincidentally, it's also a capsule because the capsule just needs a capsule collider. But unlike the other static stuff we created, because this is kinematic with the collision shape, it can move, because it's helpful when your player can move. With that done, we are going to save our scene and continue. Player collision bodies in video games are actually often capsules, even if the player is some sort of complex thing, just because it makes it easier to calculate what's going on with the environment and keep things simple. Big fancy AAA games obviously do other things, but simple video games are often just capsules. So we're going to save our player scene there and rename the kinematic body to player, and then save it again. That's it for the player scene. So we'll go back to the environment scene, and I bet you can guess what we're going to do. We're going to link the player scene as a child of environment. Now our little tic-tac man is in here. Man, woman, tic-tac creature. I'm not sure why a tic-tac has a gender. It doesn't need one. It's a tic-tac. So it's a little capsule player, I guess. It does not have a gender. You will really end up loving your terrible shapes you use, so don't get too attached to them. We're going to rotate. So click that player we've added and rotate it so it's pointing the right way, and then use the move tool to move it up. It doesn't matter that it's above the ground because we're going to add gravity. So for now, it can just sit there floating. That's totally fine. So we're going to make yet another new scene. We're going to go scene, new scene. This scene is very simple. So we're going to create a rigid body, which allows it to move in the physics system. This is a little bit different because it needs to move around the scene in a different way. So we'll cover that in a second. We're going to add a mesh instance to our rigid body. On our mesh, we'll add a sphere and make an egregious color, probably red, I think, this time. Nice egregious red. We'll add a collision shape because we want this to be able to collide because it can move. So we'll click our collision shape and add a sphere as the shape in the inspector. It's a rigid body that can move in the physics engine, which can move using impulses. It has a mesh instance to show it's a ball. And it has a collision shape, which is also a ball, a sphere. And we'll save it as ball. So ball.tscn, and we'll rename the root to ball. So it's just a ball. We're going to save our ball scene back in the environment. You'll know where this is going. We're going to click environment and link the ball scene in. So now we have a ball. We're going to move the ball up to the upper platform. So the center of all these objects is the same. It's 0, 0, which is why they always start in the ground. So they always kind of embed themselves in each other. That's why. So I'm just trying to move it over to the top platform. So sometimes it gets a bit confusing in 3D space, so it's easier to use the top view. I am using a trackpad. As I said at the beginning, this is much easier if you have a mouse. Gravity will come into effect at some point, so it doesn't matter that these things are currently floating. Next thing we need to do is make a goal. So the goal of this game will be the player tic-tac has to push the ball into a goal. Again, new scene, very simple. Making another spatial root node because this goal will not move around the scene. That's the wrong kind of node. I'm a fool. Add a spatial node. We do not need an audio stream player. The spatial node will be named goal as a child of this goal spatial node. We're going to add a mesh instance once again. And so yeah, we're going to make a very simple game where you have to push the ball into goal. Into this goal, we're going to create a cube. Ooh, what color should this be? This is very complicated decision, making things certain colors. Let's go cyan, maybe? Or, yeah, maybe. That's pretty gross. That's actually probably the nicest color we've used so far today. I'm going to rearrange this a little bit and create the static collision body because it doesn't need to move. And we're going to duplicate goal 1 after renaming it. No, I won't duplicate it. I'm going to scale it a little bit and then I'll duplicate it. Smush it a bit. Smush it like that and smush it that way. So it's like a pillar. Make it really tall. That's good enough. Now I'm going to duplicate it and move it over a little bit with the move tool. That's a goal. I recognize that anywhere. It's kind of goal posts, really. Yeah, that's good. That's a goal. I can see someone kicking a football through that. I'll save that as goal.tscn. And I'll return back to my environment scene, and you guessed it, I'll link the goal scene into the environment scene with the link button. Bring in the goal. Amazing. I'll move the goal somewhere, maybe up at the upper level, I think, today. Doesn't really matter where it goes. That's a good spot for it, I think. It's good. Yeah, look at that. That's nice. Goal's over there. That's pretty nice. Our game is taking shape. Amazing. Now we need to make a little pickup, because this is a video game. We'll make a little pickup that maybe does something if we get time. It's a video game, so video games have pickups. It's very traditional. Again, another scene. We'll add an area. So an area is something that exists to be collided with. It doesn't necessarily have any visuals. It just has an area that can tell some part of your game that something else has collided with it. So it's a really useful kind of spatial volume that has a thing inside it or doesn't have a thing inside it, but can detect something being in there. Inside our area, we will add a mesh instance, because we're going to add a cube inside it, because everything's a cube. Everything's a cube. We'll go create a new color. What color should this be? That's the real question. Maybe. Do we have a dark purple, maybe? Yeah, I don't know. Yeah, there we go. Our pickup is dark purple. We'll add a collision shape to it, because it's a thing that exists in the world. It needs to be collided with. And we'll go over to the shape and add a cube to our collision shape, because the cube's collider is also a cube. Box, not cube. Yep, okay. Yep. I've messed up the child. There we go. They both should be child of area rather than child of each other. There we go. I'm going to rename the area to pickup and save the whole scene. Pickup.tscn, and again, back in environment, I'll add my pickup. So I'll select an environment and link in the pickup. So we've got a nice pickup sitting in our environment now. I'll move it over into the corner maybe. Good spot. Fantastic. So the goal of our game is to push the ball through the goal and click the pickup. It's a very complicated video game. It's going to make a lot of money. Once we've done that, we'll save it. So you'll notice we haven't coded anything yet. So it's probably time to code something. If you run the game right now, it will do absolutely nothing. So you'll see that it is running Paris and Tim's game. Thanks, Tim, for helping me build this game originally. We're going to add a script now to make it actually do something. I'm going to click the player, going to right-click on it, and go Attach Script. And it's going to ask me what sort of script I want. I'm going to say I would like a GD script. Godot supports C#, GD script, it's kind of native scripting system, and visual scripting, which is kind of a block-based one. Today we're going to use GD script, which is a Python-inspired syntax, but is not Python. It's a really good little language. It's going to ask us what to call it. We're going to leave it by the default. We're going to click Create, and it's going to open up the inbuilt editor. You can use VS Code or any other editor you like, but Godot has a competent, perfectly cromulent inbuilt editor. We're going to gloss over this a little bit to be quick, but we're going to get it done. So we're going to create a variable with the var keyword. We're going to call it move speed. We're going to set it to 500 completely arbitrarily. Programming is about making numbers up, as we know, and video game programming is doubly about making numbers up. We're going to create a direction variable, which is a vector3, which is a vector with x, y, and z. So once we've got our move speed and our direction, we're going to continue going on here. Vector3, if you're not used to it, it stores 3 elements. So for people who are confused by that, it has x, y, and z, or whatever you would like to. It's got 3 components where we'll use it as an x, y, and a z. It represents a direction. We obviously need gravity as well. So gravity in our little world is going to be minus 9.8. I'm not sure where I got that from, but obviously has no relationship to the real world, but we'll see how it goes. Also velocity. Velocity is important in 3D space, so our velocity is also going to be a vector3, and that's all we need. We're going to ignore ready, so that doesn't really need to do anything. Ready is called when a node enters the scene in Godot. We don't need to do anything special right now. I'm going to create a new function called physics process, which is the thing called every physics tick. So Godot has a bunch of predefined functions we can use to manipulate our game world. They all start with underscore. So anything you make starts with no underscore. Anything that Godot supplies starts with underscore. We're going to set our direction to nothing, 0, vector 3, 0, 0, 0. So we're trying to get you excited about Godot rather than teach you Godot, so I'm going to gloss over this a little bit. Physics process gets called every time the physics tick happens, with the delta, which is the time since last tick. So the reason that might be different is the frame rate might be different to the physics tick, so this lets us account for the difference. So if input is action pressed, so we're going to check if a certain action in the action table, UI left, which is whatever key we've mapped to left using Godot's action table, and I'll show you where that's set in action in a second. Godot has a really powerful input system that lets you set named actions to certain keys. So you can check for an actual key, or you can check for a left, right, whatever. It's a lot easier to name things like left or right, so you can allow players or yourself to remap things. So we're going to duplicate that for left, right, up, and you guessed it, down. I can't type. I might get the directions wrong, but I'm just going to take a guess right now. So left is x1, UI right is going to equal to -1, -1, yeah, and yep, and so +1 for left, -1 for right, and Z is our up, lowercase z, not uppercase, 1, and down will be -1. Right, so yeah, X, Y, Z. We want these keys to be able to move the player around in the scene. Now I can go project settings, and you can see where these are mapped. So in the input map, you can see the UI right is mapped to a key or a D-pad. So it's mapped to right, keyboard right. You can add your own, name them whatever you like. Lets you abstract the action away from the platform that you're running the game on, because Godot supports running on consoles and iOS and gamepads and so on, and Android, whatever you'd like. Next thing we need to do is we're going to normalize the direction, so no matter what direction we go in, we're going at the same speed. So we're going to go direction equals direction.normalized. If you want to do real game dev, you need to be okay with 3D movement. It's not as scary as it seems like it is. It's often seems a lot scarier than it actually is. It's quite okay. So next thing, we're going to go dir equals dir times move speed times delta, which basically makes it move at a nice speed because we don't want it to zoot off in the distance too fast. That's pretty useful. So because this is being called every physics tick, we use the delta there as well, because if the frame rate or the physics rate was inconsistent, then not multiplying it by the delta would mean the movement speed was jolty, not nice and smooth. So this makes it nice and smooth based on how your computer's handling it. So that just makes sure that handles it properly. Next thing, we want to fall faster than we jump. So if our velocity on Y is greater than 0, so if we are not jumping, then we fall. If we are jumping, then the gravity is a different rate again. So video games are basically controlled lying. So gravity will affect us differently when we jump, basically. It's kind of like coyote time, where, in the old cartoons when the coyote falls off the edge after being off the edge already for a brief second. Video games are basically that on a mass scale. Next thing, we need to apply some gravity. So each physics step, velocity on Y, we add some gravity, which is multiplied by delta, so it doesn't add all the gravity at once. Otherwise, it'll just be awful. That's that. So once we've done that, we also go velocity.x equals direction.x, so they're the same. Velocity is a 3-part vector. We also need to z, so direction.z. So we only want to modify the y, the gravity component of the velocity. We're not modifying their otherwise velocity. So now we're going to actually make the player move. So we're going to go velocity, and the velocity started at 0. So we're going to end with an actual velocity we keep using. So we're going to use a function called move and slide, which is part of Godot, which basically moves and stops you from hitting something in the environment. If it hits something, it comes to a stop. Every game engine comes with an equivalent of this function. Move and slide is really quite useful. You can command click or control click on the function there, and it gives you a nice definition. Moves the body along a vector. If the body collides with another body, it will slide along and stop. This means you don't have to calculate all the fancy maths to move something around in 3D space yourself, and just lets you use Godot to do it. So we flash a velocity and a vector telling it which way is up. And Y is up. Y is up. Up is up. We also want to be able to jump. So if is on floor, which is another feature of Godot. If we command click on it, it returns true if the body is on the floor. So yeah, it's very useful. Only updates when calling move and slide. It's because the physics engine knows if something is colliding with something else, that means it's on the floor. Physics math can get hard really quickly. So we're going to check if is on floor and input is action pressed. We're going to leave that blank for a second. We'll come back to that. Velocity dot y equals -10. So we want to jump. Yep, 10, not -10, sorry, yes. We want to go up. That was an inverse jump. So if you're on the floor and the action press, which will create the second, is pressed, so we're going to go into our project settings and in the input map, and we're going to go find game_jump and click add. Game jump is added at the end now. I'm going to map a key to that. Jump is a spacebar. Whoops. I want to map it to spacebar, not control. Add key, space, OK. So now game_jump action is mapped to spacebar. So now I can provide the game_jump action in that is action press call. It auto-completes for me. Godot's great. That's everything we need to do for now in the script for our player. So I'm going to save player.gd with Command S or Control S and go back into the environment. I'm going to click my player, and the player now has a script attached to it. You can see over on the right side there in the inspector, player.gd. Now I'm going to push Command R to run it, and absolutely nothing will happen because we haven't got a camera. That was deliberate, by the way. Very smooth. It is doing things under the hood, but nothing is happening that we can see. So I'm going to click the environment and click plus for a new node and search for a camera. And you'll see there's a camera node. Godot's got a bunch of cameras. You've got AR cameras and VR cameras and all sorts of stuff. You can see this frostum thing which shows us where the camera is pointing. So you can see where the camera is pointing with a little preview button. So I'm going to rotate the camera to have a nice angle to make it slightly more useful. That's slightly more useful. A little bit more rotation down, and then we'll have a nice camera. Now if I run it, we should have an actual view. Yep, look at that. Oh, we can move the player with the mouse, with the keyboard. Can even jump. Look at that. It falls a lot quicker than the rate it moves at, which is great. Everything seems to be working. The camera is not following the player, which is not very good, but he move and slide works. He hits the wall. They hit the wall. It's doing very well so far. We're going to continue improving this a little bit. I can jump off the world too. Way. Camera didn't follow me though, so I'm going to go back to Godot. And I'm going to drag the camera onto the player. So now the camera is a child of the player. The camera will now follow the player. This is a very crude camera follow. You could write a nice little script so the player follows the camera follows the player around like Mario 64. So you have a cameraman, like a lerp and stuff, a nice flow. But now the camera is following the player at least. So this is a lot better. I'm going to fix the key mapping because the key mapping is actually backwards. So I'm going to go into just backwards, forwards. Yep. Go back into the GD script and modify the key mapping. So plus equals 1. Yep. And we're going to run that again. Oh no. It's just rotated slightly. Sorry, I've got my keys around the wrong way. So I'm going to go UI up. UI down. I'm 90 degrees relative to where I needed to be. So UI left, UI right. Our left was forward. Yeah. The strings. So you need to. Yep, there we go. Okay. Perfect. Look at that. Now I can actually control it. Everything's working. Now I can drive around, get up the ramp. The ramp's a bit easy, but there you have it. So we're going to make the goal work next. I can push the ball. Oh, look at that. Okay, there's no knowledge for the game that it scored the goal though, so we're going to go into the environment. We're going to click on the ball. I'm going to tick the little box that says can sleep. The ball's been falling asleep when it doesn't move, which means it doesn't respond to physics very well. Now pushing the ball around will be a nice, pleasant rolling experience, because the game was kind of putting the physics system to sleep. Look at that, it rolls nicely instead of just flying forward. Beautiful. I'm going to add a little bit of code to make the goal know when the ball has gone through it. So, first thing I'm going to do is go into environment and add a script to the environment, which will let us reset the game. So this means we don't have to restart the game constantly. So tweaking the game is a lot easier when you can reset the game. In the process call, which is called every frame, I'm going to go if input key pressed, key enter. So unlike before where we mapped a nice action, we're going to brute force map the enter key. I'm going to go get tree, which just gets the whole node tree, and reload current scene. So now when I push enter, the game resets. Look at that, beautiful. Extremely useful. With that in place, I'm going to go to the goal. On the upper platform, I'm going to add an area, so I'm going to move the scene a little bit so I can see what's going on. I'm going to click on that upper floor, and I'm going to add an area to that, which is the same kind of volume thing you saw earlier. There's the area. So I'm not adding the goal to the goal scene, I'm actually adding the goal to the main environment scenes. It kind of is overlapping the place where the goal is in that scene, just for detection purposes and to make scripting slightly easier. So in that area, I'm going to add a collision shape, and add a box. So this box basically says what shape is the area that is detected. This is the area, the invisible area that can detect when something is inside it. So you can see the invisible area represented by those lines. Anytime the ball goes through the area, we score a goal. This is a very easy game. I'm going to make it a tiny bit thinner, just so it's slightly less easy. That's better. Yep, okay. Now it's not so easy. With the goal ready to go, we need to actually do the scripting component. So we're going to add a script to the game to let us score that goal. So I'm going to click on the area. I'm going to go node, and you'll see this node emits a bunch of signals. So these signals are things that can be connected up to code to make it do things. So the area emits a body entered signal and tells us which body entered it. So I'm going to click body entered, click connect. It's going to ask me where I want to connect it to. I'm going to connect it to the environment, which adds a on area body entered function to the environment script that we created. So I'm going to delete the contents of that, and inside that I'm going to go if body is rigid body, which basically means it can only be the player. We're going to print hooray goal. We haven't got time to make a UI today, but this will print a nice little message to the console when the player goes through the goal. Sorry, the ball goes through the goal. I'm going to move up here. I'm going to push the ball through the goal. And it says, hooray, goal. Because it knows the ball has gone through. Because it can only detect the ball. The ball is the rigid body. Amazing. That's pretty much our whole game. I'm going to go quickly and make the power up do something, because we've got a little bit of a second to do that. I'm going to click on the cube. I'm going to add a script to it. Everything needs a script. Attach script. Pick up. Inside that script, I'm going to uncomment process, so every single frame, please rotate. So we're going to go rotate dot x underscore x deg to rad. So process is called literally every frame. So we're going to basically rotate it at the delta rate on the x and rotate it on the y. And we're going to run it, and now our cube will spin like a proper video game power up. So that was Godot. Hope you enjoyed it. Please dive into it and build more things, or extend this silly little game. Please tweet me any questions you have. Thank you for watching. Hope you're all staying safe. You can export your game to Mac, Linux, Android, consoles, a whole bunch of things. Thanks very much.
Hello everyone, and thank you so much for your talk, Paris. There was some great chat in the chat room during that, which was really great to see. If you had any questions for Paris, I hope you asked them during the chat. That was a really great presentation. Seems like a really cool tool. Next up, we have a break. It's a great time to get up, stretch your legs, stretch your hands, eat some food, drink some coffee, pat your cats, send photos of the cats to the Pets of LCA channel in Venulus, or go to the Linux AGM, which is at 12:30. And if you're a member of Linux Australia, you should have got an email about that. So the next talk in this room is after lunch at 1:30 p.m. AEDT from Russell Coker. It's 20 years of NSA Security Enhanced Linux, a retrospective. So I'll see you all there or in later talk or later on. Have a great lunch.